Okay, so what we're looking at today is, so yesterday or previously we had looked at our scatter plot, and we've got, so we make sure we find out what the EV, the RV is, and we constructed a scatter plot. And then the last lesson we looked at creating that line, or the least squares regression line. And we looked at writing that out. So we had the A, which was the y-intercept, and then we have the B value, which is the slope. Then we put the variable names in the y and x spot. So now what they're going to do is they'll ask you to interpret those values. So they may ask you to interpret the slope, or they may say the B value. Or they could use the gradient, but generally they say interpret the slope. So with the big hint with any of these, every time in your general maths, if you get asked to interpret, you will know in my notes I have there's a statement, like a fill in the blanks, that you write, okay? It's so that we're clear and we don't get marks deducted for not saying it correctly. So all you have to do is follow this. So if, for example, you had an equation, so say, for example, it looked like this. So I'm just making that up. So you can see the B value is this one, and the sign is positive. So if it was positive, you would write the positive statement, this first one here. So we don't write y and x. We're generally being given our variable names. So if I go back to our height and weight example, say I was interpreting it, I would say the weight increases by, and I'd put the B value and I'd put the units. So if we were talking about weight, it'd probably be kilograms, yeah? So I'd say the weight increases by, let's say, it was that one there, 3 kilograms, when the height increases by, and we just always say one, and the height's probably measured in centimetres. So we might say 1 centimetre, okay? So that's what you got to do. If it's negative, you write the similar statement, but what's the word that's different there? It decreases, so it goes down. So that's for the B value. So, and down here, if you're asked to interpret, and maybe just write very big above that, the A value, because a lot of you don't seem to notice that you do have the sentence for that. So when you're interpreting the intercept, that means the A value. Now also, sometimes they call it the vertical intercept because it's the vertical line. Maybe just write that above it as well. So in case they said it in the question, you don't get confused. All right. So if you have to interpret that, so say my little example, what's the A value up there? It's 5. I would say the regression line intercept predicts if I was using the weight to be 5 kilograms when the height is 0 centimeters, okay? So you just have to use that template and practice it. So let's have a look. Let's have a practice on these questions. So it says the regression line is used to model the association between time in hours a group of students spent studying for an exam and their mark. And the equation line is this. So looking at this, before we go on with the questions, what variable is my response variable? Which one of those? Mark. Good. So just put it above. That's your response variable. And obviously time is the other one, the explanatory variable. So at the moment, they're just asking you just have to write down the value of the intercept. So what is that? It's just a simple answer. Which one is the intercept? What number?
30.8.
Yeah, 30.8. So remember, this is our A value and this is our B value, and the intercept is the A value. Okay, so if you are answering this, you just say 30.8. Okay, Now, it says to interpret the intercept in terms of the context of the variables above. So we are going to do that answer. I'm just going to do it underneath. So hopefully you've got enough room there. So it says interpret it. So I go, okay, I've got to interpret that. I'm going to go to my little statement, and it's the intercept. So off I go. I'm going to write it out. The regression line. So I'm following off my notes there. The regression line intercept predicts now I have to put the response variable, which is in this case the mark, to be, now I'll say 30.8 because that was what I have to put, and it doesn't say what I said percentage, so 30, that's the units, 30.8% when the EV, this time is 0, and what did they say they measured time in? Hours. Okay, so underlining, I'll go just highlight. These were the things we had to change or fill in. They're yellow on your template. You needed to fill them in. All right. So then let's have a look at B. So B saying write down the value of the slope. So the slope is the B value. So what's the value of the slope in this example? 1.62. And now it's asking me in part 2, so B part 2, it's asking me to interpret the slope in the context of the variables. So off I go. Now, first of all, I've got to look at it. Is this a positive B value or a negative B value? It's positive. So see there, it's a positive. So off I go and I'll write the positive statement. So it says and I've got to put the RV, so the mark, that's what I had to fill in, increases by, and I'm going to put the B value, 1.62. Now, I've got to put the units, which was percent, when the time increases by 1, and we say hour. Okay, so 1 hour. Okay, so they're the things I put in. Okay, a regression line is used to model the association between the time in hours students spend doing household chores and the hours they spent part-time work, which ranged from 0 to 8 hours for this group of students. The equation of the regression is here. So chores equals 8.0 minus 0.3 times work. So which one is my RV? Which chores or work? Which one's my response variable? Chores. And work is my EV. So if you write that above, then you won't get it wrong. Okay, then it says write down the value of the intercept. So remember, that's the A value. So what's the A value in this one? 8.0. Good. And now it's asking me to interpret. So off we go. You're going to go and interpret that. I'm gonna pause the video in a minute, and then we'll do B and you'll interpret the slope, which we can see is what's the value of the slope? A negative 0.3. All right, I'm going to pause it for a sec and you go and write it. All right, so let's have a look here. So the first one, when we had to interpret the intercept, the A value, it says the regression line intercepts predicts it just says chores, but it sort of doesn't make sense. So I chose to say the chores hours to be 8.0. So you needed to fill that in, hours when the work hours is 0. Okay, so that was the other thing. So that's done. And then when we had to interpret the slope is negative. So it says the chores, so the chore hours, sorry, I probably shouldn't have S there, but the chore hours decreases. Now this is because we write the word decreases on a negative, when it's a negative gradient, we don't need to put a negative in front of that 0.3. That decreases represents the negative symbol, okay? So you don't need to put the negative. Who put that in there? Anyone put that in there? So just you write decreases by 0.3 when the work hours. Sorry, I should have put hours in there, shouldn't I? Yeah? Did you put that in there? When the work hours increases by 1. Okay, so now we've looked at interpreting our regression line. So if you want to just remind yourself, the regression line is that A plus BX. Okay, now what we're going to do is we're going to use this line, this equation, to predict values. So I'm going to go down and look at the example down here so that we can practice. So it says the equation relating weights in kilograms and heights in centimetres of a group of students whose heights ranged from 163 to 90 is given. All right, so we can see here we've got our RV is weight and our EV is height. And we've got an A value of -40 and we've got a B value of 0.6. Okay, it says use this equation to predict the weight. So because we have a formula for weight, we can predict it using these heights. So if we go and look at this A, the first one, what we're going to do is every time we're going to substitute that height into the formula. So it'd be -40 plus 0.6 times, now this first one was 170. And so we're going to end up with a predicted weight. All right, so they're predicting it to be 62. So 62, and remember weight is getting measured in kilograms, so kilograms. So have a little think about it. These were students, because if you think about logically, if it's off, then you may have made a mistake and that will help you. So I'm thinking 170 centimetre child at 62 kilos. That's not unreasonable, isn't it? It wouldn't be unheard of. So that one is okay. So you think, yeah, I'm doing wrong. If you do something where you got like it was 6.2 kilos, have a think about it. That's not right, is it? So you might have entered something wrong, and that's how you can pick up a mistake. So always think logically as well. So then if we go and look at the next one, let's do the same thing. We're going to predict the weight of a child that's only 65 centimetres. So this is obviously a very small child, yeah? So we're thinking they're not going to weigh a lot. So what was their one? We popped that in, and we got, oh, what did we get? Yeah, we got -1. Now, so let's have a look about, that's okay. So we're going to write -1 kilograms. Now, that does not make sense in terms of our data, like predicting, does it? We don't have a negative. So what happens is, if we look at this, what they did is their data, they only collected, kids were only from 163 to 190. So that was the age group that was the range that they collected from. So it's not going to be reliable when you check, and as we can see, if we start using this formula for children that are smaller than that, it doesn't even prove to be right. And so that's why it's important that we know what we're predicting. So in this first one, when we predicted a value, so can you see that this 170 in here, it is within what we predicted. So see how it's 170 is within 163 and 90. So if you have a look up on the scatter plot, oh no, it's a different one, sorry. But if you think about it, so if we had this as a scatter plot, sorry, I'm going to do it for you. So if we had weight and height, so if we had weight and height, what you'd see on this scatter plot is the first dot would be 163 height and the last one was 190. So we didn't have any other data other than that. So when you predict within those values, so if you predict, see how 170 was inside that, that's called interpolation. It's within your data. So sometimes you get asked, so this one would be interpolation. So just write that. That's an interpolating prediction. And then when you see 65, 65s would have occurred outside. So if you look here, anything smaller than 163 or bigger than 190 was outside. So we call that extrapolating. And it's important to know because someone could say you're extrapolating there. You don't really know. You haven't looked at data above that, okay? So just right next to that one, that this one is extrapolating. So just, or extrapolating or extrapolation. So if you look up on my little example there, which was a different one with the mark and the hours, so we look like our smallest time in hours was here, whatever that one is, and our largest one was, let's just say, you know, around the 30, okay? So if you are predicting any value in here, that would be interpolating. If you're predicting any value after those or before it, that would be called extrapolating, all right? So that's how that works. And you will need to know, they'll say, make this prediction. What can you say about this prediction? You can say it's interpolating or extrapolating. And if you notice, with the interpolating, and this is a good little statement to say, it is a reliable result. Highlight that, because they'll just ask you, is this reliable? So if it's interpolating, it is, because it's the data we looked at. Anything that is extrapolating is not reliable. So maybe just write that, not reliable. Use that word. All right, so that's it.